Hi girls, today we're looking at logarithms. For some of you this is a completely new concept, so I'll try to go slowly. Okay, so we've been working with exponential functions, which is like this first one here. So if fx equals 10 to the x, and that's this exponential function there, then the inverse of 10 to the x is log base 10 to the x, which is this function here. So what I want you to take from that is log is the inverse of an exponential function. So let's write that down. The log function is the inverse, or you could think of it as opposite, of the exponential function. So it's the opposite of an exponential. When you apply it to an exponential function, it cancels out the exponential function, because every type of function needs to have an inverse. You know, sine has inverse sine, cos has inverse cos, multiplying the inverse is dividing, things like that. So the inverse of an exponential is a log. Okay, so to give you more understanding of how to work it out, basically, look at these examples here. If you've got 2 cubed equals 8, and then you perform on both sides log base 2. So see how the base of the log has to be the same as the base of the exponential. So what happens when you do that is it cancels out with that base. The log cancels out with the base of 2 of the exponential, and then you're left with just the power of 3 on that side. Now, on the other side, you've just got this log 2, 8. There's nothing to cancel out with. So the log has a base of 2, and it's the log of 8. You can actually, you actually can't put that one in your calculator, but let me show you. Let me show you another example. If you had 10 cubed, we know that equals 1,000. Now, you can do the log base 10 of both sides. So the log base 10 of that and log base 10 of that. Now, on your calculator, girls, there is a button that says log, and it's got, it just has LOG on it. So it's a button that looks like LOG. And I'm talking about your scientific calculator now. Don't use your graphics calculator for this. Now, girls, first of all, what we've learnt is the log base 10 should cancel out with this base, and you just get 3 on this side here. And then on the other side, you get log base 10 of 1,000. So this reads as log base 10 of 1,000. So what it's asking you for is what power of 10 becomes 1,000? Well, that's 3. 10 cubed is 1,000. Now, if you do the log in your calculator, you'll get the answer of 3. So on your calculator, press the log button, and that automatically does base 10. So that's already taken care of for you. So press log, then input 1,000, and press equals, and you should get your answer of 3. So what it's actually trying to find, so you can see that it worked because it found the right answer of 3, but also like what it's trying to find is, let me say, what this is asking for, what this expression here that I'm writing in blue is asking for is it equals the power of 10 that creates or gives 1,000. So 10 to the power of what is 1,000? Oh, that's 3. So it equals 3. So the log is actually finding the power of its base 10 that gives this as the answer. So that's what it is. So for instance, let me give you another example. Log base 3 of 27. So what that's asking is, what power of 3 gives me 27? Well, that's actually 3 to the power of 3. You can work that out on your calculator. That's 27. So that equals 3. Let's try another one. What's log of 2 to the log of 8 base 2? What that's asking for is, what power of 2 equals 8? Again, that's 3 because 2 cubed is 8. Let's try another one. Log of 5, 25. Log of 25 base 5. So that's asking you, what power of 5 gives you 25? Oh, that's 2 because 5 squared is 25. Are you seeing the pattern? Hopefully you're seeing the pattern. So basically what that means is, according to what I've written here in algebra, it says if b equals a to the x, then the power x equals log of b base a. That's what we've actually been doing here. Because like from this one here, we know that 5 squared equals 25. So look what happened. The power went over here. The base went to the base. And the 25 went here. That's the same thing as this, what happened here. So if you've got a base to a power equals some answer, then log of the answer with the same base equals the power. Now that might all sound confusing, but it's actually, I think the best way to understand it is using these numerical examples. Okay? So the log is actually finding the power of a that gives us the result of b. So, before I move on, I might actually just keep doing these numerical examples. So, let's try a question. Question 1, find, without using your calculator, girls, A, B, C. Log base 2 of 16. Log base 6 of 36. 36. Log base 3 of 81. Okay, so let's have a go. So again, the log is like another name for the power. So what power of 2 gives 16? Well, that's actually 2 to the 4. 2 to the 4 equals 16. So the answer is just 4. And actually, girls, you can use your calculator if you don't know some of these powers. These actually can't be done in the calculator, like the actual, but you can't enter this in the calculator yet. We'll learn about that later. Next, what power of 6 equals 36? Well, that's 6 squared equals 36. So therefore, the answer is the power, which is 2. What power of 3 is 81? You might have to do this on the calculator with a bit of trial and error. 3 times 3 is 9, 3 9s are 27, 27 times 3 is 81, so it's actually 3 to the 4 is 81. So the answer is 4. So hopefully you're seeing how log works. Log finds the power that the base needs to be 2 to give the answer of 81. So hopefully that makes sense. So now we're going to look at logs of base 10 and only base 10 at first. So in other words, they're all going to be written as base 10, so now it's 10 to the power of something, okay? So when we use logs without writing a base, we assume the base is 10. So if I just write log of 5 and I forgot to write the base, we actually assume it's a base of 10. Okay, remember, log base 10 is the inverse operation to putting something to the power of 10. So the operations cancel each other out. So, for instance, log of 10 to the x, the log and the 10 cancel each other out, and you're just left with x. It also goes with the other way. If you've got 10 to the power of log x, the 10 and the log cancel each other out, and you're just left with x. And this works for x bigger than 0. We'll talk about that later when we look at the graph in more detail. Also, log of 10 equals 1. Why is that? Let's think about that for a second. Let's write it with the base to make more sense. Remember how we did before. What power of 10 gives 10? Well, 10 to the 1 equals 10. So therefore the answer is 1. So log of 10 equals 1, because remember this log of 10 is the same as log of 10 base 10. Hopefully that makes sense as well. Okay, so now, without using a calculator, find log of 1,000. So remember, we're wondering 10 to what power equals 1,000? Oh, that's 3. Therefore, the answer is just 3. Now, this one's a little bit more confusing. So log of what? So what power gives the fifth root of 10? Hopefully you realize 10 to the 1 on 5 gives the fifth root of 10. I've just written it in index form. So since 1 on 5 is the power, oops, I made a mistake there, didn't I? That should be 5. So since 1 on 5 is the power of 10, the answer is just 1 on 5. Okay, now question 2. Use your calculator to write the following in the form of 10 to the x, where x is correct to 3 decimal places. Okay, so use your calculator. Okay, so basically, we're going to use the fact that log and the exponential 10 to the power of something cancel each other out. So for instance, so remember that 10 to the power of log of anything, x, cancel each other out and just leave x. That's the whole idea, because they're inverses of each other. Putting 10 to the power of something and finding the log of it will cancel each other out, because that's the whole idea behind the inverse. And you can actually check that by, for instance, with the example of 9. That means the 9 actually equals 10 to the power of log of 9, because the 10 and the log actually cancel out and it equals 9. So before we go any further, actually put that in your calculator to show yourself that it does in fact equal 9. So put all of this in your calculator by pressing 10 to the power of, and then press the log button and put 9 in. Press equals. Oh, you might need to cancel the brackets. Close the brackets. And you should get 9. So that's why those two expressions are equal to each other. Now what they want is it in the form 10 to the x. So we want the 10 to be there, but we need to find the log 9 as a decimal to 3 decimal places. So in your calculator now, just put the power, just put log 9. And you should get 0.954. That's what I got for log 9. And that's what they want in the form of 10 to the x, and that's what this is. Okay, similarly, 0.6 can be rewritten as 10 to the power of log of 0.6. So, once again, we put this part in our calculator so the 10 stays there. So put log of 0.6 in your calculator and I got negative 0.222 to 3 decimal places. So they're the answers there. We're just rewriting it. We're just learning how to rewrite it and deepen our understanding of logs. So next question. Use your calculator to find the value of log 3 and log 30. So you're literally just putting it in your calculator. Log 3 is, I got 0.477. And log 30 is 1.477. Okay, so that's interesting. They're difference by 1. So now we need to explain why log of 30 equals 1 plus of log of 3. Now let's think about that for a second. What's the relationship between the number 30 and 3? Well, 30 is just 3 times 10. So log of 30 is log of 3 times 10. Now we can use the fact that if log of 3 equals 0.477, that means 10 to the 0.477 equals 3. Because remember, the base is 10, so that's the power of 10. That gives 3. So that gives us this exponential equation here. So I can now rewrite this as log of 10 to the 0.477 times 10 to the 1. 10 to the 1 is just 10. But wait a minute. What can we do with base, two indices of the same base, and we're multiplying them? We can just add the powers. So this becomes log of 10 to the 1.477. I'm just going to rub out the other workings so you don't get so confused. Okay, and now wait a minute. Well, log and 10 should cancel out as always, so that should equal 1.477, which is 1 plus 0.477, which is 1 plus log of 3. So that was a bit of a tricky one there. Basically, you had to use the fact that if log of 3 equals 0.477, 10 to the 0.477 equals 3, and then sub it in there. So we're kind of showing through working how they're related. Now, find x if log of x equals 4. So remember, what you can do here is put both sides to the power of 10 to get rid of the log, because we're thinking, I want to get rid of log. What's the inverse of log? Well, that's 10 to the power of log. So if I put both sides to the power of 10, look what happens. The 10 and the log cancel out, so I'm just left with x on this side, which is great because that's what I want to find. And 10 to the 4 is 10,000. Same thing with the next one. If log of x equals negative 0.451, if I put both to the power of 10, the 10 and the log cancel out, and x equals, now I'm going to put all of that in my calculator and see what I get. And I get 0.354 to 3 significant places. Okay, now girls, all of that corresponds to exercise 4A. Take your time with it. I know this, for a lot of you, this is a very new concept. Have a go. But girls, I would like to move on to the next little bit because it's just using the same ideas. So I just want to do these examples as well. Okay, So write an equivalent logarithmic statement for 2 to the 5 equals 32. Now remember, girls, I think of it this way. The log always equals the power. So I put the 5 over here. The base stays as the base of the log. And then the 32, the answer goes there. So that's just rewriting it. So log of 32 base 2 is 5. And that's true because 2 to the 5 equals 32. And that's what the log is asking. It's asking what power of 2 equals 32, and that's 5. So that's how you rewrite an exponential equation in terms of a log equation. Okay, similarly for the next one, 4 cubed is 64. The log always equals the power, which is 3. The base of the exponential becomes the base of the log, and the 64 goes there. This is using what we had previously in our booklet, which is here. This part here. To go from an exponential equation to a log equation, the base of the exponential becomes the base of the log. The power becomes what the log is equal to over here, and the answer that we got from the exponential goes into the log. So it's the log of the answer to the base, and then equals the power. Okay, now let's go question 2. Write an equivalent exponential statement for these log equations. Okay, so here we've got log of 243 base 3 equals 5. So that can be written as, so the base becomes the base of the exponential equation. This is always the power, so it's 3 to the 5, and it should equal the 243. You can check that on your calculator, that 3 to the 5 does in fact equal 243, so it's true. Over here, the base is 10, so that's the base of our exponential equation. The power is 4, so it's 10 to the 4 equals 10,000, and we know that's true as well. So that's good. Question 3. Find log of 9 base 3. Remember, what that's asking you for is 3 to the power of what is 9? Well, that's 3 squared is 9, so let's make a note of that. 3 squared is 9, therefore log of 9 base 3 just equals 2. Now, 2 to the power of what is 64. Now, you may need to do a bit of trial and error on your calculator, but I believe 2 to the 6 is 64. So, therefore, the answer of log of 64 base 2 is 6. Next one. Log of 0.25 base 2. Okay, well, think about it this way. 0.25 is just a quarter. So 0.25 equals a quarter, which equals 1 over 2 squared, which equals 2 to the negative 2. So negative 2 is the power, so that's our answer. Now, here are just some notes in this section here. So, as we know, log of 9 base 3 is 2 because log of, now 9 can be written as 3 squared. So, and it equals 2. Log of 8 base 2 is the same as log of 2 cubed base 2 because 8 is 2 cubed. And that just equals 3 because, well, the power is 3 and also the log 2 and the 2 cancel out. And back here the log 3 and the 3 cancel out. Log base 10 of 1,000 equals log base 10 of 10 cubed because 10 cubed is 1,000. And that just equals 3. So what does that tell you? Log of any base of that same number base to a power just equals that power. And that's what we've been using already. So that's fine. use the above rule to find these. Well, that's actually the same as before. So once again, 2 to the power of 6 is 64. So that just equals 6. Now, I'm happy for you to just go straight to equaling 6. You could also write it as log of 2 to the 6. And then these cancel out and you just get 6. Now here, this is an interesting one. We've got to find this as a power of 3. So let's have a go with that. So let's find the cube root of 9 equals, well, that's the cube root of 3 to the 2, because I need it as a base 3. Then, wait a minute, the cube root of something is just to the power of 1 over 3. So it's 3 squared to the 1 on 3. And then, what is that as just 3 to the power of something? Well, 2 times a third is 2 on 3. So the power is now 2 on 3, so that's my answer, because remember the log always equals the answer of 2 on 3. Next, I need 1 on root 5 as a power of 5. So let's have a look, 1 on root 5. And the fact that I want as a power of 5, that's because this number here is 5. So now, that becomes 1 over, what's the bottom as a power? That's 5 to the half. And then to bring it all up into the numerator, it becomes negative a half. So then my power finally is negative a half, so this just equals negative a half. So as you can see, girls, you really need to be good at your index laws. So that's an absolute necessity for this topic, so if you need to revise them, please do.